Hello, my name is Andre, and today I'm going to show you how to launch Talos operating system in a testing mode on your local computer using QEMU. Talos is a operating system, modern, immutable, security focused, and specifically made to run Kubernetes, uh, which can be run on a variety of bare metal hardware in the cloud. And also, if you want to try it out, you can try it out in Docker and using QEMU. Docker is quite limited in terms of what is supported, while QEMU offers a full virtualization, so you can try Telus with the Telus kernel with exactly the same way as Telus would run on bare metal. I'm going to follow the documentation on running Talos on QEMU. I have some of the dependencies already pre-installed on my machine, so I'm not going to cover that in this video. I will assume these dependencies are already installed. This includes the QEMU itself and the various CNI plugins which are used to create the networking for on your host to support the cluster of Talos-based virtual machines powered by QEMU. So first thing we need to do, we go to Talos GitHub and releases. And for each Talos release, I'm going to use the latest one, 07 Alpha 6. There is a list of assets. And what we are going to need is like few of them. First of all is the Talo Ctl, which is the CLI tool used to control Talos clusters to access the Talos API and also to create local clusters which can be used for testing. So I'm going to need the AMD 64 version for Linux and I'm going to run Talos AMD 64, so I need to bootstrap the process. I need the init ramfs image for AMD 64 and the Talos kernel image for AMD 64. In fact, I have those already downloaded. So I download the init ramfs, the VM Linux, and also I downloaded the Talos Ctl and renamed that so it's easier to use. And now I have everything I need to actually create my cluster. Let me switch on the light so you can see me better. I'm going to use talosctl cluster create command. Then I have to give the provisioner name. It is going to be QEMU in my case. And then for the initial boot, which is really close to what the bare metal boot is, the VM will be completely empty. There is no like disk image. So I have to provide the initial Linux kernel and init ramfs, which will be Telus, which is very similar to the way on bare metal the nodes are initially PXE booted. So I'm going to provide the VM Linux, which are downloaded, and init ramfs, which I already have here in this directory. Then I need to tell cluster create how many master nodes I want to create and how many worker nodes. So I'm going to go with 3 masters, HA control plane, and 1 worker. Each node requires approximately 2 gigabytes of RAM when running under QEMU. And so like this means that 4 nodes will require 8 gigs of RAM on my computer. So I'm going to start this. And actually I made a small mistake. As in QEMU mode, Talos requires the networking which is set up by CNI and creating the bridge interface. We need to start that as root. So I'm going to use sudo with -e flag so that sudo keeps the environment intact so that even though it runs as root, it will still create all the necessary data directories in my home directory, which will be easier for me. So I'm going to start this once again. So at this moment, the first step is creating the Telus configuration. Telus is completely secure out of the box, so it created a fresh set of TLS certificates, tokens, and whatever is needed to boot Talos and to access Talos from my local computer. So we'll have the client config as well. And while the nodes are booting, the Talo Ctl is waiting for the nodes to boot, waiting for the API to be available. And then Talo Ctl is going to trigger the bootstrap, the initial bootstrap process on the node, which will, like, because we're creating the cluster from scratch. So one node will be bootstrapped and other nodes will automatically join this first one. I'm going to show you what Talo Ctl is creating. So all the data is going to .talos directory, and then under clusters, there is a folder created for my cluster. By default, the name is Talos default. And you can see there are like a bunch of files created there. For each VM, and I have 3 masters and 1 worker, we can see there is a disk image, there is a log file, there is a configuration, the PID file, which is used to control the VM. There is also a load balancer created automatically for the Kubernetes control plane. There is a like state YAML. There is a small database used to DHCP the nodes. So while the nodes are booted, they're going to be DHCP is going to provision the initial network configuration for them. We can follow the logs of the VMs. Basically, that's the serial console logs, and see what's going on there. So currently, the VMs, they got booted with the initial intrmfs and Linux kernel. And now they're pulling the container image for the installer. Actually, all of them are doing that. My internet connection here is not like really great, so that takes some time. And as like all 4 nodes are pulling this image, this certainly takes a bit more time than a single node. What Talos already offers, and we can cover that in another video, is a way to use registry mirror caching on your local computer, so you don't have to download those images over and over again if you're doing some testing, creating clusters, destroying them all the time. So what is going to happen next? The installer image gets pulled from the container registry, and you can see that the installer image contains the tag, which is the version of Talos I'm going to install. And the same installer image is driving the upgrades of Talos when the new version gets pulled. And the installer contains the kernel, the initramfs image, and various tools, so it can handle the partitioning of the node and also formatting the file systems. Installer image is driven by the configuration. Here in this example, we're kind of flying in autopilot mode. So Talo Ctl cluster create pre-creates all the configuration for us. It's correct. It's like has the if we're running on bare metal, the default configuration might need some tuning to fit the actual hardware. For example, what is the install disk name? Basically, what is the boot disk going to be used? If the network configuration requires something else than DHCP, then probably there should be special configuration for the network, and so on and so forth. We can also, while this is pulling, take a look at the networking infrastructure which got created on my computer. So we can list the IP, the interfaces, and we can see that I'm doing this on the wrong machine, sorry. I got confused why I don't see the interface. I am expecting to see. So Talos is going to create the interface called, let me make this a bit bigger. It should be called Talos and then some random numbers. Here it is. You can see this interface, right? And this interface will be assigned the IP address. This is a bridge interface, the IP address of the bridge, which will be on the host, and each provisioned VM will have its own IP interface, which is directly reachable from the host as well. But let's get back to our VMs and see what's going on there. Oh, that is a bit of unfortunate for this video, but my internet was so slow that actually this bootstrap process gave up on me, so it decided that it's taking too long to boot the VM. So I can show you how to continue from this state. So if my internet was a bit faster, this would have been a better experience, but let's try to continue. What I have to do, I have to manually bootstrap the first node if that node is ready. So by the end of this cluster create process, actually the Talos config got generated. I can see if my first node is ready. I will issue one of the easiest commands version, so I can see that this node is ready. It responded back with its version, so I can now bootstrap it. That is called the bootstrap process. And now the node is actually the first node is bootstrapping. We can see this, for example, by listing the services. So all these commands I'm running are running over Talos API over the network. So you can see that on this node, the etcd process is the first thing which gets bootstrapped is running. And also the boot cube is running, which is creating the self-hosted Kubernetes control plane. This will take a bit of time because that is also requires pulling some images. We can look at other nodes. So there is another master node here. And you can see that etcd is preparing, which means that it's preparing to join the cluster. Well, it will be able to discover the master node. And once it discovers, it will join the cluster back. What we can also do is we can launch the health check. It's the same health check, which is yeah, of course I can remove this finally, which is run usually when we do Talo Ctl cluster create, but will launch it manually. So we can see like the progress is basically checking that etcd is healthy, that boot cube is running, and so on and so forth. So while the nodes are booting, we can see, for example, the services on this node. Okay, etcd is running, which means that it successfully joined the cluster. And now I can actually, it's the second master node, and we have the third master node, ap.4. And this one also joined etcd, so things are coming together. How I actually came up with these IP addresses, I can do cluster show provisioner QEMU, and I can see the cluster state, which was created. It has the network, which is of course configurable. I'm just using the default. That's the gateway address. That's basically the bridge interface, and I have 4 nodes. 3 of them are type control plane or master, in other words, and they have IP starting with .2, 3, 4, 3 and 4, and the last node is the worker node, which has the address .5. What I can do right now, and once again, if Talo Ctl cluster create worked for me without timing out, and that's my internet connection, this would have been done automatically, but I can do this manually as well. I can pull the kube config from one of the Telus nodes, so we'll have the config for kubectl. So I'm going to tell to pull it from one of the master nodes. It's going to pull the config and merge that into my default Kubernetes config, right? So if I do kubectl get nodes now, I should get the information about, oh, sorry, I typed kubeconfig twice and that is doing a bit different thing. This is going to work. So I already have the cluster with the name Talos default. That's because I was running this before, so I can, but that cluster is long gone, so I can simply overwrite the config, tell Talos to overwrite that. And now I can do the kubectl get nodes, and I can see that all my nodes I created are there. They're ready and join the cluster. I have 3 master nodes. So I have a Kubernetes cluster, 3+1, running on my computer now. I can do like -o wide, and I can see that it's running the Kubernetes 1.19.1. That is also configurable, but that's the default version with this version of Talos. It's running the OS Talos 0.70 Alpha 6, the kernel version, and so on. And I can do like get pods and see that all the system pods are running, the full Kubernetes control plane, the core DNS containers, and the pod checkpointer, which is specific to this self-hosted control plane and bootkube. I can get back and explore a bit the Talos Ctl. What are the other commands available? For example, I can give the Talos Ctl an IP address, that's the IP address of the node, and launch the dashboard command, which provides me like a nice CLI top-like experience. So I can see the node resources, how they're being used. This is node resources used by the virtual machine, right? In my case, as the QEMU is using the KVM to basically accelerate the virtualization. It's running almost native speed, and we can see how it's using the network, disk, the processes, memory, whatever. But the actual power of Talos Ctl and the Talos API is that I can also add multiple nodes and query them simultaneously. So you can see that now I have like several tabs for each node, and I can switch between them. So that's the first node, the second node, and the third node. And the same applies to any other command I used. For example, I can see the services from all the nodes at the same time. So this is the output, and in the first column we can see the node address and the service name for each node. I can also, for example, run some command like listing the contents of the directory on all the nodes, and I can see that of course it's all the same on all the nodes, but it's pretty powerful that I can do this in a single command or read contents of some file that is probably not going to run on multiple nodes because it's hard to see what's the semantics of that, but I can get back to like a single node and read the contents of the file. There are lots of APIs. I can see like the dmessage, so that's the kernel. I can follow that if I want to see the messages appearing in real time. I can list the network interfaces. I can get the routes and so on and so forth. And all these commands are working in a single node case or multiple. I can also, for example, reboot the master node, and you can see how quickly it comes back because right now all the images got pulled. So you can see on the right, it's the serial console log of this node. It took roughly like 3 seconds to boot the Linux kernel, and now we're 10 seconds since the boot, the kubelet is starting. API-ID is running. API-ID is the Telus service, which is powering the actual API. etcd is running, and 24 seconds, the node is up. There's like scary looking error messages. It's the CNI working. In our case for Talos by default it's Flannel, but it could be any CNI you like, Cilium or Calico. And the node is like fully up in roughly 20 seconds, right? So it's ready. All the pods are running. I can show that. I can also, using the API, using Talo Ctl, I can upgrade the nodes. And as it's all API driven, I can use Talo Ctl, or I can write my own wrapper around that and do any kind of automation using the API I can reboot the nodes, I can upgrade the nodes, I can gather information about the nodes, I can gather some stats, what being like memory usage or processes or anything else you can imagine. I can deploy applications to this Kubernetes cluster. I can test the HA scenario. I can bring down the node and see what happens, and so on and so forth. For example, I can show you that Telus is immutable. So in this HA scenario, I can always like lose a single node and lose a single master, and when it comes back, it will like recreate its state completely from the other masters. Etcd state, whatever Kubernetes state. So I can use the reset command, which means leave the cluster and wipe the disk. And I'm going to do this, for example, on another master node. So in under QEMU, reset is going to cause the reboot. So when the node will reboot, it will be completely clean. It will pull the installer back again and install the Talos and join the cluster back. Let's see how it happens. I'm triggering the reset, and you can see on the right, once again, the console log for this server. It's currently draining itself. It's stopping everything, stopping Kubernetes, stopping all the services, removing all the pods which were running on this node. It takes a bit of time for all the pods to be terminated. And when it finishes that, it's going to unmount all the file systems, getting like completely clean state, wipe the disk, and reboot. It actually rebooted. Now it is pixie booting once again from that image I downloaded initially, like in the real data center scenario, there will be real pixie booting, and you can see it's pulling once again the installer image, and the installer takes a bit of time to pull, like I said, and on my pretty slow connection, but it should be faster this time because it's just a single node. When I started this video, it was like 4 nodes pulling that image simultaneously. And once it pulls that, it's going to perform an install, reboot, and then this node is going to join back the cluster. So at the moment, Kubernetes sees that this node is not ready. You can see that's not ready, and scheduling disabled, so it's drained because we wiped this node. That's what Talos did to this node to signal that. And if we were, for example, resetting this node and our plan was to completely delete this node from the cluster, we can kubectl delete this node and like join a new one. In my case, the same node is going to join. It will have the same host name, the same IP address. So I'm not going to do anything. And once the node joins, it will become ready and it will uncordon itself once it joins successfully. So we're still waiting for the installer. It got installed, rebooted, and now booting into Talos from disk actually, and starting all the services, and it's going to join the cluster back based on the configuration it has. So you can see the API ID started, which means that I can access this node using the API ID. Of course, I'm not going to reboot it once again, but I can see the services running on this node. So you can see the etcd is preparing, kubelet is preparing. This includes, like for the kubelet, includes pulling the image from the image registry. Kubelet is running. It's going to be healthy soon. And we can see that etcd is running, and you can see the live health checks. So usually when the kubelet first boots, it takes some time for it to respond on the health API. So we can see this initial health check failure, and now it's all good. And the uncordon node has started, and we can see the state of the node. It still hasn't changed yet, right? It will take some time to be reconciled. Let's go, not the wide output, but this one. You should see the node is ready, and it's soon going to uncordon itself. And we can see the pods, And you can see these are the pods which are starting on this node back again. So the Kubernetes control plane is once again becoming HA. When I reset the node, it went from 3 masters to 2 masters, and now this third master is joining back, and all the pods are being created once again. And you can see that the Kubernetes control plane is completely healthy. And if I want to verify that, I can run the health command. You can see that right now it should discover all the nodes, right? Because my cluster is like fully built right now. When I ran for the first time, it was still bootstrapping. And it checked that etcd is healthy on all the node, that bootkube, which runs on the bootstrap, that is not needed now. API-ID, so the service which powers the Talos API, is ready on all the node. All the expected Kubernetes nodes are there, are ready. Control plane components, kubeproxy, core DNS, and all the nodes are schedulable. So after I finished playing with this, I can simply destroy this cluster. I do cluster destroy, provisioner, QEMU, and that is going to remove everything which was created, including the state directory, the disk images, the networking, the interfaces. So I got exactly to the state when I started this video, and I create another cluster with different settings like more RAM, more CPUs, less RAM, different Telus version, different CNI, or whatever else I might want to test. Thanks for watching. Links to the Talos documentation, Talos releases are going in the description of this video. Thank you.